Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Professor Shailesh Patel, and we are going to continue our examples of belt drive. So before starting the example, first of all we see the formula which we will use in these all examples. So most common formula we will first of all check that, and after that we will start the example. You can see here the speed ratio n2 upon n1 is equal to d1 upon d2. N2 is the rpm of driven divided by rpm of driver is equal to diameter of pulley of driver divided by diameter of pulley of driven. Okay, second formula is a belt velocity of belt, which is denoted by v, which is equal to pi d1 n1 upon 60 is equal to pi d2 n2 upon 60. Because right now we have not considered the slip between the belt. Okay, so velocity of belt will be same for the driver and driven. We are not considering the S1 percentage of slippage between the driver pulley and belt, and S2 percentage between the belt and driven pulley. So we are not considering the slip right now. So this is the basic formula: pi d1 n1 upon 60 is equal to pi d2 n2 upon 60. After that, third formula, which is very important, because length of belt pi r1 plus r2 plus 2x plus r1 minus r2 whole square divided by x. So this is the formula. Okay, so remember that, means you know that for cross belt this type of driver and driven is there. You know that in cross belt is crossing like this, and for this type of arrangement you know that there is a positive plus r1 plus r2 whole square is there. So remember that there is a minus for open belt, and cross for cross there will be only plus. This is the very small change in this formula. Okay, so now next is a T1 upon T2 is equal to e raised to mu theta, because in power and other all formulas this T1 and T2 must be known, means tension in the tight side and slack side we have to find that, and for that we will use this formula T1 upon T2 is equal to e raised to mu theta. Okay, and sometimes this theta is not given, we have to first find this theta. So for that theta we have the formula theta is equal to pi minus 2 alpha. Okay, we know that theta, this theta angle of rep is equal to pi minus 2 alpha. Okay, so if we can find the alpha, you can find the alpha by geometrical relation sine inverse r1 minus r2 by x. If we are solving the cross belt type example, there will be plus, and if this is a open belt there will be minus. So same we have to remember that where we have to change for the cross belt, right? Okay, so alpha you will find sine inverse r1 minus r2 by x, and whatever you find their answer will be in a degree, so we have to convert that in a radian. So pi into 180 we will multiply, and you will find the alpha in a radian, and now theta is equal to pi minus 2 alpha. Okay, after that you know that power transmitted by the belt, the equation is a T1 minus T2 into velocity, means effective tension into velocity, tight side minus slack side into velocity is equal to power. Okay, now next is for maximum power transmission. Sometimes they ask find the power, but maximum power, and if they say maximum power and centrifugal tension, we will if the mass is given, density is given, this type of data is given, then during the all the relation we have to consider the centrifugal tension, because you know that centrifugal tension is equal to maximum tension divided by 3. So Tc is equal to T by, if we want to find the velocity, we consider velocity is equal to T upon 3m. If this is data is not given, so velocity we will find by this data maximum tension divided by 3m. So we will find the maximum power here. Okay, after that if we want to find the Tc, mv square, but always m is not given. m is a mass, m is a mass per unit length. Okay, so this mass per unit length is not given. So first of all we have to find that, and for that always density is given. Sometimes they give the density, width, thickness. So we have to find the mass of belt per unit length, and mass is equal to density into width of the belt and thickness of the belt into 1. We know that mass is equal to density into volume, and if we consider the unit length, and after that initial tension, if the centrifugal tension is not considered, T1 plus T2 divide by 2, and if centrifugal tension is there, we have find it the Tc we will use here. Okay, and T1 plus T2 plus 2 Tc divide by 2. Okay, this is the formula. And after that maximum tension in a build, sometimes if we want to find this velocity but this maximum tension we don't know, or we know the velocity, and if you want to find this stress, this formula is used. Maximum tension is equal to stress, this is the stress, sigma into B width into T. You know that force is equal to stress into area. So same type of this formula, tension means force in a Newton, stress into B into T, and this stress is a allowable or maximum stress for that belt. Okay, so this is the formula for the belt. Okay, let's solve this simple example. Let's first read the data. Two pulleys, one is a 450 mm diameter, so diameter is given, and the other is a 200 mm. Okay, are on a parallel shafts 1.5 meter apart, means there is a distance between two pulleys is given. Distance between two pulley is given. Are connected by the cross belt. Remember this, there is a cross belt type of arrangement is there. Okay, so first of all check this, find the length of the belt. We have to find the length here, length, and the angle of contact we have to find the theta here for the each pulley. What power can be transmitted by the belt, so we have to find the P here. Okay, if when the larger pulley rotate at a 200 revolution per minute RPM, if the maximum permissible tension in a belt is a 1 kilonewton is given here, and the coefficient of friction between, so this data is given, and we have to find here this length of belt, angle means angle of lap between pulley and belt, and power. So first of all, what is the data is given, we will write the data given here. So diameter is given here. Okay, so let's consider this 450 as a D1. This is the D1 is given here, and this D2 is given here. Then this 1.5 meter means distance between two pulleys. You know that if these two pulleys are given, distance between from this to this, total distance x is given here. Okay, so x is given. So connected by the cross, find the length, angle, and power. This RPM is given for the larger pulley. If you are giving the number here D1 for the 450, so you will write this larger pulley means this RPM we have to consider for the as a N1. Okay, and if maximum tension is given, so this is the tight side, maximum tension in a tight side, T1 is a 1 kilonewton, and the coefficient of friction means mu is given. So this is the data is given. So there is a mass, density, not given in this example. So this data is not given. So centrifugal tension, we will not consider the centrifugal tension here. This example is without considering the centrifugal tension because mass, density and all other data is not given. So we will consider without. Okay. So this data is, we have written here, D1 is a 450. So we will 450 divided by 1000. So in meter 0.45, and we want radius R1 because in our formula there is a R1 and R2. So this radius and R2 is a 0.1. Okay. X is given here. N1 is a RPM. This T1, this maximum tension is given 1 kilonewton. So 1 kilonewton we will convert as 1000 Newton, and mu is equal to 0.25. Okay, let's start. Okay, so first of all we are going to find the length here. L is equal to, we know the formula is equal to pi R1 plus R2 plus 2x plus R1 minus or plus. We know that there is a open belt drive or cross belt drive. We have to check this, open or cross. This is, you can see here, this is connected by the cross belt drive. So we have to take here positive. If this is an open belt drive, this will be negative here, R1 minus R2, but it is a cross belt drive. So we will take here positive R1 plus R2 whole square divided by X. So you can see the pi R1 is equal to 0.25, R2 is equal to 0.1, X is equal to, you will put the 1.95, again R1, R2 and X. If you put all this value, and you will find the length is equal to 4.975. Okay, you will find the length L is equal to 0.975, and answer will be in a meter because you have converted this in a meter. First of all given in a mm, but you have converted into meter, so your answer will become in a meter. Okay, so you have found the length here. Okay, after that we are going to find, we want to find the power. So check this, power is equal to, so check this, power is equal to T1 minus T2 into velocity. So first of all we have to find what is the we have. So T1 is given, but we don't know the T2 and we don't know the velocity. So first of all we will find the velocity. Velocity of belt is equal to, we already know that pi d1 n1 upon 60. So if you put this value pi into diameter, is diameter in meter, so 0.41. So we'll put this value 0.41 here, 0.45 into RPM is 200 and divide by 60. So you will find the answer is 4.714 meter per second. Okay, so you will use this velocity here. Now we want to find the tension, T2 tension in a slack side, because tight side is 1000 is already given. So how we will find this T2? So for finding this T2, you have the formula like this, T1 upon T2 e raised to mu theta. Okay, so mu is given, T1 is known, but we must need this theta. So we will find the theta, and for theta you have the formula. First of all we have to find the alpha here. You know that alpha is equal to sine inverse R1 plus R2 by X, and you will find the alpha here because R1, R2 and X is there. So you will find the alpha in degree, you will find the 9.6 degree, and after that you have to convert that into radian, and converting into radian you will find the theta here. Theta is equal to, you know that theta is equal to pi plus 2 alpha. Here plus is there because this is a cross belt drive. If this is an open belt drive, this will be minus, pi minus, but it is a open belt drive. Okay. So pi plus 2 alpha, and you will find this here theta is equal to 3.477 radian. Okay. So this is the theta you have, and this theta we will use in this formula here, T1 upon T2 e raised to mu theta, and you will use this theta here and you will find the T2, and this T2 you will put here and you will find the power. Okay, so this is the total example calculated here. You can see how you will find the length here. Okay, but remember that there will be plus, and in power you will use this equation T1 minus T2 into velocity, but for that velocity you will use this formula pi d1 n1 upon 60 and you will find this velocity. And for T2, okay, for this T2 you will use e raised to mu theta formula, but for that you have to find this theta here. You will find this theta. Okay, it is very basic example because mass, density, centrifugal tension, initial tension is not considered here, not given is here because this is very small example, but this can be lengthy if centrifugal tension is given. Okay, thank you.